right, so the next thing that we want to look at is our turning points. So the points at which the polynomial function switches direction. So we've been talking about the end behavior, but now we want to talk about what's happening on the inside, or these little things that happen in between our two endpoints. So where we switch directions. If the turning point is higher than any of the nearby points, so meaning there's things to the left and to the right that are lower than it, we will call those a relative maximum. Right? And so that means we have something like this shape. We have is what we write in the what? Relative maximum. If the turning point is lower than any nearby points, it is called a relative minimum. And that would mean we kind of have a valley, right? We have a low point compared to the things to the left or to the right of it. Maximum and minimum values are called extrema. So these are the high points, the low points on the graph, not necessarily the end behavior, that it's its own thing, but things that we can see right there on our screen, like right there on our graphic calculators. These turning points define where the function is increasing or decreasing. So anytime we have a maximum or a minimum, that means we're changing either from increasing to decreasing or decreasing back to increasing. And we can use our calculators to find these exact points or very, very close to it. So the first thing we want to do is we want to use our graphing calculators. We want to plug in this equation into our y equals. So we've got x cubed, so x to the third, minus 6x squared, plus 7x. And so we just plug in our equation. Now we want to look at the graph to find the local maximums, local minimums, or the relative max, relative min. So plug in your equation, and then we want to hit graph, which again is that top right gray button. And so once we have our graph, we can see we do have a maximum here. We also have a minimum here. We have a relative max, relative min. But I want to find those exact values. And so if we move our cursors around, we can kind of get close, but it's not going to give us the exact number. So what we're going to use is we're going to use the calculate function on our graph to find that. And so we can do that by doing second calc or second trace. And that opens up this calculate menu. And we have the options of minimum and maximum. So let's find the maximum first. Okay, so I'm going to hit enter on maximum. And it gives me this prompt. It says left boundary question mark. And so what it's saying is, if this is my graph, what I want to do is I want to find a boundary or some point to the left of that maximum. So I'm going to move my cursor with my left arrow, right arrow. And I'm just going to put it somewhere to the left side. So I'm going to say, I want to make my left boundary here. So my cursor's to the left of that maximum. I'm going to hit enter. So when I hit enter, now it says right boundary question mark. So I'm going to move my cursor to the right side of the maximum. So once my cursor starts going back down, I know I've passed that peak. I'm going to hit enter again. And so now my calculator has these two boundaries that it's looking in on. And so this calculator just has two little arrows. It's going to check in between those two boundaries for the highest point. And it says guess question mark. And I'm like, yeah, I want to guess. I want to know what that highest point is. So I'm going to hit enter one more time. And it says my maximum is at the point 709, or just 0.71, or 0.71. And the y value for that is 4.3. 4.30. Now I want to find the minimum value as well. And I'm going to do the exact same steps, but this time I'm going to use minimum instead of maximum. So second trace, go down to minimum. And so I'm interested in this little valley here. So I'm going to be on the left side, left boundary, hit enter. Move to the right side. And as soon as my cursor starts moving up, I can hit enter again. Guess in between those 2 points, and my minimum value is at 3.29 and 4.30 as well. Except negative 4.30. And so there's my minimum and maximum values, okay? Or relative minimum, maximum values. The next thing that it's asking us for is our increasing intervals and decreasing intervals. And so the way we find our increasing intervals, decreasing intervals, again, we kind of look at the graph itself. Again, when we're increasing, that means as we move from left to right, our y values get bigger, right? We're going up. So if we're increasing all the way up to the top of our maximum. So we're increasing up to that highest point. Well, in this case, to the left side is negative infinity, all the way up to the highest point of our maximum. So we're increasing. So our increasing interval is from negative infinity up to the point of 0.71. And then our decreasing from that maximum, we start decreasing down to from our high point of 0.71. We start to decrease, right? We're going downhill all the way down to our minimum value, which is at 3.29. At which point we start increasing again, right? And we increase all the way to infinity. So we have two increasing intervals, and so we can separate those with a u. That u just means or in conjunction with. And so we start increasing again from this x value, 3.29, all the way to infinity. Right. And so again, maximum minimums are separated or separate the increasing, decreasing values. Right? We're increasing up to our maximum, then we start dropping back down, so we're decreasing at the minimum, then we start increasing again back on the other side. Any questions on maximum, minimum, increasing, decreasing? So let's do one of these problems together. So the directions says graph each polynomial function using a table, then give its domain, range, turning points in behavior, and intervals for which the function is increasing and decreasing. So we look at number one. They give us negative x cubed plus 3x squared equal to f of x. And so first thing we want to do is we want to take this, plug it into our calculator. Okay. So go to y equals, clear out whatever's in there, negative x to the third, plus 3x squared. And so then what I want to do is I'm going to graph it just to get kind of an idea of what's happening. I'm going to add a little, let's say that sideways S. And so what I want to do is I want to be able to grab points off of there. So to grab good points off of there, I'm going to go to my XY table. And I'm going to take some of those points. So to get to our table, we're going to hit second and then the graph button again, or second table. And so if I'm looking at that, 20 is too big, but starting at -1, I can start grabbing points. And so from -1 to 3, I have points that are going to be on my table or on my graph. So I've got 4, 0, 2, 4, 0, 2, 4, 0. And so these points I can easily put on my graph. So -1, I'm at 4. 0, I'm at 0. 1, I'm at 2. 2, I'm at 4. And 3, I'm back at 0. So if we look at our graph, once we have our points plotted, we can go ahead and connect those. That way we have a good, accurate graph on our paper. Yes?
My calculator's not letting me grab.
All right. So then we need to start answering these questions on the right side of the page. So the first thing it asks is, what is our domain? Negative infinity to infinity, right? Domain, again, is the set of all of our x values. So we're going from negative infinity to infinity. We have all real numbers. So again, we could do this. We can also just say we've got all real numbers, right? We can use that little R symbol, just an R with a third leg. Either of these would be fine. What about our range? Our range is the set of all of our y values. So starting from the lowest y value to the highest y value, what do we have in this case? Negative infinity to infinity, right? Lowest value up to our highest value, they're all connected. Negative infinity to infinity. Next question is relative maximum and relative min. So let's find our maximum. So again, we're going to use our trace function, or our second calculate. I'm going to go ahead and do our maximum first. So move my cursor to the left side of my maximum, hit enter. Move the cursor to the right side of the maximum, hit enter, and guess in between. It says my maximum is at 2, 4. And then let's find our minimum. Second trace, minimum. Move to the left side of it, hit enter. Move to the right side of it, hit enter. Guess in between. Now notice on this one it says my minimum's at 6.6976. 6.6976. E to the -7. All this E is saying is this is scientific notation. So what they're really doing is they're saying this 6.6976 times 10 to the -7 power. I meaning this decimal place is going to move 7 spots to the left. So 1, 2, 3, 4, 5, 6, 7. So what this number really is 0.000000066976. So what is that really? What would you round this to? 0, right? So our relative minimum 0. And then the same thing happened for the y value. This says 1.346 e to the negative 12, which again is just 0. So do not put an answer of 6.69, right? That's clearly not at 6.69, which would be way over here. It's at 0, 0. Okay, so even when you read these, make sure to read that whole number. If you've got an e to some negative exponent, it's going to be that number, right? So if you had something like 1.23 times, or e to the negative 12, right? Still just 0. Doesn't matter what these two numbers are. You got something e to the negative 10, 7, 12, you're given 0, okay? So then the next questions are, what are our end behavior? So as x approaches infinity, f of x approaches what? As we move to the right side of the graph, where are we going? Down, as we're going towards negative infinity. And then as we approach negative infinity, so as we go to the left side of our graph, where are we going? We're going up towards infinity, right? And then the last thing is our intervals. So we want to know where we're increasing, and we want to know where we're decreasing. So I'm going to do decreasing in red, increasing in green. So we're decreasing as we move from left to right and we go down. So we're decreasing all the way to this minimum. Then we start increasing up to our maximum, and then we start decreasing again from there on out. So we start off with decreasing. And again, we're talking about our x values or parts of our domain. So our domain, of course, all the way to the left will be negative infinity. Up to our first minimum. So where was our first minimum at on our x value? 0. So we're going from negative infinity up to 0, decreasing. At which point we start increasing. So from 0 to, where's our maximum value?
Infinity.
So 4 is on the y, but we're talking about our x value, so 2. So we increase from 0 to 2, and then we start decreasing again. So in union with, from 2, here's where we go to infinity, right? All those x values to the right are decreasing. So we go from.
How do you know when to do it?
So again, increasing, decreasing intervals are broken up by maximum and minimums.
Right. So your decreasing interval will be your maximum, and your increasing
On one of the sides, yes. Okay, because every time you have a minimum and a maximum, you're going to have one side's increasing, one side's decreasing. Okay. So anytime we have a minimum, of course, your left side will be decreasing, your right side will be increasing. Anytime you have a maximum, your left side is going to be increasing, your right side is going to be decreasing.
Okay, which one goes on the bottom? The intercept interval and decent intervals? Is it the top one or the bottom one?
For what?
Right here.
The increasing, decreasing?
Is that one right there?